This talk is this a platform? Platform engineering before PMF. Do you know that feeling when something just fits so nicely, it's satisfying in a way you just can't describe? Well, product market fit, or PMF, is kind of like that. Your product rocks, the market likes it, and someone's willing to pay for it. Early on, a company has one singular goal: to reach product market fit. Hi, I'm J.K. Jensen. I'm a production engineer at Mysten Labs. I'm a father of a 3-year-old girl, and I like running long distance. I'm going to talk today about what it's like to build a platform before reaching product market fit. So I heard about platform engineering a few years back. I was sitting around looking at this 15-year-old Xeon box that we were running our infrastructure on over Wi-Fi that I brought from home. And I was thinking to myself, is this a platform? Is this what it looks like? And hey, what even is a platform? What is platform engineering? A few years ago, this guy, Patrick Dubois, invented DevOps. He's the one you can hold responsible for tearing down the wall between dev and ops and for banishing the operations team from the land. I'll give you a moment now to either throw your tomatoes or pay your respects. And no, he's not dead. Then these guys entered the scene with team topologies, driving a new era of integrating production operations into software teams. Platform engineering as a discipline incorporates all of these concepts into a single role, which emphasizes building systems and tools to increase engineering velocity and high leverage work. Many platform teams treat their platform as a product, with internal engineers as the customer, guiding the roadmap based on their feedback and behavior. This is clearly something every organization that's producing software would love to have. But who actually created it? Let's just say I have my theories, but nobody knows. The problem, though, is that building out a robust platform with rich integrations and deployment tooling, quantitative standards, and the ideal IDP is incredibly expensive, financially and in engineering time. And at an early stage, using an off-the-shelf solution is probably overkill. When a company hasn't yet reached the growth stage, it almost always prioritizes PMF over everything else, whereas the goals of many IDPs today are stability and growth. If the company can't survive, an IDP does it zero good. I want to show you one of my favorite quotes. Yes, your CTO said this to me, and no, I'm not making it up. If you don't believe me, I want to show you a definitely real, absolutely not generated by AI photo of them presenting it to me. Great, now that you believe me, let's move on and talk about how we can convince the CTO that building something that resembles a platform will be worth it. How are we going to do that? I will suggest that we follow the advice of a good friend of mine named Hagrid and follow the patterns we see in what the organization is building, focusing on reducing the toil that surrounds everything except company priorities. Here's some of the patterns we saw in the services Mysten engineers were building. They were containerized applications, stateless, and used a common set of dependencies. They used a shared observability stack, were exposed to the web, and were largely templatized. Over the course of a year, we saw rapid growth in the number of services being built and deployed. Almost all of them followed these same patterns, and at the beginning, there was significant manual work involved in bringing up each individual new service. We knew automation in this one area would yield faster bring-up times and a more enjoyable engineering experience across the entire company. As a brief aside, let me share with you how one platform engineer made a difference. His name is Elliot. Elliot Alderson showed how to build a great platform as a nimble team. He protected business value by automating low-leverage work. He attacked toil for the sometimes necessary evil that it is. And he built a great platform to help his startup be more productive. Rumor has it, he even used Pulumi. Following Elliot's example, we built 2 systems to support what we call the Mysten service, a representation of what a typical service we bring up looks like. The CLI handles the service lifecycle process from an engineer's perspective, and the Mysten service abstraction is a Pulumi common library used to let an engineer bring a Docker container and get back a service with minimal configuration. One piece of the CLI is that it used to initialize permissions for an engineer doing work on our infrastructure. Nowadays, that's not necessary anymore thanks to Pulumi ESC. ESC lets us get temporary credentials based on the Pulumi credentials from the user for any given session and lets them get to doing their job without having to bootstrap permissions along the way. The first step in the process is SweUp service init, which does exactly what it sounds like. It initializes the service with new boilerplate code and also works within our monorepo or in a new repo. And right away, an engineer gets to start writing business logic. They don't have to worry about setting up logs or metrics or health check endpoints. That's all set up for them using our standards and best practices. Then the engineer will run SweUp docker generate, which will bootstrap a Docker file for their project. Then they can use SweUp CI image build to build an image for their project. This will use our remote build infrastructure in our build cluster to maintain deterministic builds. And build will also be integrated into the Pulumi template that we'll see. Then they use SweUp Pulumi init -- service to stand up a new Pulumi microstack for their service. We use microstacks because it allows teams to operate independently and to iterate quickly. There are also options for -- app for application-specific services and -- basic for core infrastructure. The code this command generates will use the Mysten service abstraction that we talked about earlier. Here's the image building code. We use a dynamic resource provider to wrap the remote image build. The engineer supplies a repository from within our organization and a ref to build from, and it will be treated as a standard Pulumi resource and get built when a Pulumi update is run. The code also grabs the kubeconfig provider from ESC, authorized by the engineer's Pulumi identity. We initialize some default arguments, including passing in the image URI from the image that was built in the previous slide. After initializing the args, we can tune them as necessary. You can see some recognizable Kubernetes configuration, but also our DNS configuration, which allows the engineer to define a subdomain and incorporate TLS by default and optional more complex configuration like proxy rules. This all culminates in the actual resource creation, which will build the image, set up the deployment, configure the network, and expose the service to the internet. Now that the code is ready to go, the engineer can stand up their service using PulumiUP. And just like that, the service is running a production level deployment. The engineer can iterate on it quickly and independently. Here are some examples of services we've built using the Mysten service abstraction: the SweNS IO application, Inoki by Mysten Labs, and the Oracle Red Bull Racing Bybit collectibles. As we built each of these services, we tuned and added new settings as they were required, avoiding adding new complexity unnecessarily. So we built something, but is it a platform? What we built is a haphazard arrangement of microservices, tools, and infrastructure as code held together mostly by my blood, sweat, and sheer willpower. So, of course, the answer is a resounding yes. Here's what we accomplished. We drove down time to production from 1 week to hours. We reduced the direct dependency on the production engineering team and our time to bring up a new service. And maybe most importantly, we made a lot of friends along the way. I'm JK Jensen. You can find me at most of the regular places as After Ephemera. Thank you so much.